There's a larger book that I've just had for about the last year that's called How to Know the Ferns and Fern Allies. And this is by John T. Mickle. And this is an older book, but you can still find it on Amazon. This gives line drawings of the ferns, but very detailed descriptions of each of the ferns. And so I use these three books together as I'm learning about new ferns. And I know one of our members talked about, the different parts of a fern, and this is from the Hollowell book. And the first 6 pages have some great information. I'm going to go through this at a rather high level, but just to talk about these names, because you'll hear me mention some of these terms as we go forward. So on the left-hand side at the top, you see the frond, which is the whole leaf, blade, and stipe. The being the leafy part and the stipe being the stalk. On the right-hand side, you'll hear me talk a lot about the rachis, which is the stalk within the blade. The pinna, you see how they've highlighted it green? It's the entire primary division of the blade. And then below that, the pinnule, you see the very small green, it's just highlighting one of those lobes. Down at the bottom, you've got the rhizome, which is the underground stem, and the root. Okay, so there's a lot of information on these pages. I'm not going to go through it in too much detail, but just to give a brief overview, this gives you a basis for when we start to look at the actual photos. So up at the top, and someone mentioned this before, you've really got to look at the overall shape of the fern. Is it broadest at the base? Is it shapy? Then in the middle of the page, you look at how it's divided. Is it once divided, twice divided, thrice divided? What's that shape of the pinna? And at the bottom of the page, you look at the margins of the pinna and the pinnule. Are they smooth or toothed or lobed? So let's look at an example here. So here are some photos. First of all, again, look at the overall shape of that fern, and then look at the shape of the pinna, and finally look at the margins. So you see I've got the ebony spleenwort top left, the hay-scented fern top right, maidenhair fern bottom left, and the sensitive fern. And we'll talk about them more in detail, but these are the things that help you to identify these ferns. Next, look at how that fern grows. So at the top of this page, is it clustered? Does it grow in a crown? Is it individual? Then what about the stipe, which is the lower half of the stalk, and the rachis, that upper half in the leafy portion? Is the lower half, is it scaly? Is it hairy? What are the characteristics of the stipe and the rachis? And then at the bottom of the page, keep in mind to look for other features, and we'll talk about ferns that are opposite versus alternate. On the right side of this page, they talk about reproductive features, and I'm going to talk about fern reproduction at a very high level in just a few minutes. So here's an example of different stipes and different growth forms. So on the left, you have the intermediate fern. You can see that it grows in a crown on the top of a rhizome, and the stipes are very scaly. In the center is the hay-scented fern, and that grows individually along a rhizome. On the right-hand side, the lady fern, which grows in clusters, not really as tight of a crown as an intermediate fern, but a cluster at the top of a rhizome. So you can see just an example here of things to look for when you're looking at these ferns to help you identify them. Now, we look at the photos of the native ferns, you're going to see, we'll talk about the sori, the sporangia, and the sporangium. And the sporangium being the small round cases that hold the spores. And we're going to look at a photo in a minute. You can see the sori, which are clusters of these sporangia, or cases of spores. And then at the bottom of the page, look at how those sora are arranged. Are they marginal? Are they along the midvein? Are they scattered? We're also going to talk about photos of fertile fronds. You can see that up at the top half of this page, and vegetative or sterile fronds. So let's talk for a second about an indusium, and we're going to see a picture of that in just a second. What is an indusium? An indusium is a thin layer of cells. It's a flap of tissue that covers the sporangia. And as the spores ripen, this flap of tissue pulls back. And I'm going to switch to the next slide so you can see an example of an indusium. So here, do you see that flap of tissue? This is on the ebony spleenwort. The flap of tissue that covers the sporangium until they mature. And you can see that this one is starting to pull back and release so the spores can be released. This is also a good example of a kidney-shaped or a horseshoe-shaped indusium. So let's go back to the previous page and look at some of the indusium shapes. And this again is from the Hollowell book. And see, look at which fern best represents that shape. So at the top, you see kidney-shaped. Those are the wood ferns, round, the Christmas fern. And we'll look at a photo of these in just a minute. Star-shaped, elongate, and curved as in lady fern. Cup-like as in hay-scented fern. And no indusium at all as in our polypodes. Here is an example of some of those shapes on the sori. So on the left-hand side is the marginal wood fern, and you can see that it has a kidney-shaped or a horseshoe-shaped indusium. On the bottom left is the Christmas fern, and that has a round indusium, and you can see all those sporangium starting to be exposed as it's pulling back. Top right is your lady fern. You can see how it's curved over the midvein of a leaf. And the bottom right is a polypody with no indusium at all. Back on page 5 of the Hollowell book, you see the term at the bottom. It's called skeletonized. And they're talking about plant parts that hold the sori. Skeletonized, and we'll look at a picture in a second, refers to a fruiting stalk or a leaf part that's much narrower than the normal fern leaf. Examples of ferns that have skeletonized leaves are the cinnamon fern, the sensitive fern, and the royal fern. So let's take a quick look at that. So here's your cinnamon fern, and there's the skeletonized fertile leaf. It's a separate stalk, and you can see the shape of it. Here is the skeletonized pinna on the interrupted fern. And you see how they are in the middle of the rachis. And as they mature, they fall off, leaving an interrupted space. But these are skeletonized pinna that form over those sori. And here's the sensitive fern. And again, you can see the skeletonized leaf. It's actually the pinna curling around the sori to become bead-like. Hopefully you can see that in the photo. So I told Dan I was going to just do some basics, things that I learned when I was first starting to really get into the ferns. And I said, well, what is the difference between pollen and spores? Both of them are a fine powdery substance. And the photo on the right is a lady fern. I just put that on a piece of paper the other day, and that's what I ended up with after about 24 hours, was the beautiful spores on my piece of paper. So what is the difference between pollen and spores? Pollen is always male. It must combine with the ovary on the plant in order to form a fertile egg or seed. Spores, on the other hand, are a bit more complex. Spores transform into a plant that produces both male and female cells. So let's take a quick look at the life cycle of a fern to see how that works. Here is the life cycle of a fern, and let's start at the top left of the page. You can see where I added number 1 in a red circle. I added the red to the photo of this page. A fern is a diploid, just like you and I are. So what is a diploid? A diploid is an organism whose cells have two sets of chromosomes. You can see that on the left side of that graphic. We humans have cells with two sets of chromosomes, one from our mother and one from our father. However, we can create an egg and a sperm with one set of chromosomes, which is a haploid. And that's what you see on the right-hand side of the screen. So in the same way, the fern creates a spore, and the spore has one set of chromosomes. Now let's go back to the graphic from Hollowell again. So we looked at the upper left, there's the mature fern with two sets of chromosomes. Follow the green arrows up on the upper part to number 2 on the upper right. The fern creates spores with one set of chromosomes. Now is the interesting part and what is unique about ferns. If you look at the lower right, that spore with one set of chromosomes grows into a tiny green plant. And that green plant produces both a female and a male cell. And then those chromosomes come together to form a young fern, which again is a diploid. So fascinating to me that the fern has the ability with a spore that has one set of chromosomes to create a plant that then can produce both male and female. So let's talk about other plants that produce spores that may not be ferns or fern allies. For example, non-vascular plants such as mushrooms or fungi produce spores. Lichens and liverworts produce spores. And algae produce spores. So I wanted to talk today about fern allies, and I use this website quite a bit. It's the ITIS, ITIS website. I use it to check the current scientific names, which we know are changing all the time, and to do research on various plants. And it helps me to see how things fit into different families. And this is where I started to learn about what is the relationship between a fern and a fern ally. In many of the books, you'll see both of them included in the same book, Ferns and Fern Allies. How are they similar and how are they different? So on the ITIS website, you can see the taxonomic hierarchy that starts at the very top of this page. You see the plant kingdom, your highest level of plants. Then as you go down that list, green plants, land plants, then mosses, liverworts, ferns, and seed plants. And if we break that down, you get into tracheophyta. Those are your vascular plants. And here is where you see both ferns and fern allies. They're in separate subdivisions, but they're both under the same division of tracheophyta, which is your vascular plants. Down at the very bottom of this little screenshot, you see spermatophytina. Those are the seed plants. Those are our wildflowers that we're so familiar with. So you see that all three of these are the three divisions under vascular plants. So first of all, I'm going to talk about the first subdivision, which is Lycopodiophytina, and that's where most of our fern allies are. And in Lycopodiophytina, you guys will have to pardon me if my pronunciation isn't accurate. There's a lot of tough words here. You see three groups under this section. There's quillworts, there's club mosses, and there's spike mosses. And these are the three fern allies. They reproduce by spores similar to ferns. And let's take a quick look at each one of those. So here's a photo of a quillwort. Here's a photo of a spike moss. And here are photos of several of the club mosses that are in our area. There's a fun article on a website called JSTOR Daily, and it's titled "The Many Unexpected Jobs of the Club Moss Spore." And It talks about a few things that you may not know about the club moss, and I wanted to tell just kind of a fun story as we go along. This website I really enjoy. It's a website that provides free access to a digital library of academic journals and books, and it covers every subject, including plants. So how many people have seen this club moss? It has several different common names, such as running cedar, fan club moss, or ground pine, and it's one of a number of different club mosses in our area. What is interesting is the history of how the spores from the club moss were used. If you put these spores in the palm of your hand and put a match to it, nothing would happen. However, the spores are explosive enough that if you threw them up into the air and put a match to them, they would ignite. The spores were used in the first internal combustible machine around the year 1807. They were the original flash photography and used in fireworks. And how many of you remember seeing the flash of fire in the original flash photography? They were used as the flash of fire in old-time magic tricks. They were also once used as a base for cosmetics, a fingerprint powder, and at one time a powder for latex gloves. They were also used as a coating for pills since they repel water, so it would slow down the pill from dissolving in your mouth. And they were used as a stabilizer in ice cream. So more recently, they're using these spores in studies to track sediment movement down rivers. The spores were stained with fluorescent dye so that they could be traced downriver to see how quickly the sediments were moving and where the sediments were ending up. So if any of you are familiar with this plant, imagine trying to harvest enough of the spores to meet the needs of these different industries over the years. So I wanted to share that story, and hopefully next time you see this little club moss, you'll have a greater appreciation for its history. So I'm going to go back to the ITIS website and the three groups of vascular plants. So we talked about Lygopodiophytina, our fern allies, and next we're going to talk about Polypodiophytina. This is where our true ferns are, and horsetails are another fern ally. And again, we have the third group that we're not going to talk about today, the Spermatophytina, and that's where our wildflowers are. So let's look at Polypodiophytina in a little bit more detail. It has 4 subclasses. The first one being the horsetails, which is a fern ally. And you can see here is a photo of a horsetail. The second class under there, these are your most primitive families of ferns. And these are ferns found in Hawaii and Micronesia. The third group, Ophioglossaceae, contains your adder tongues and your grape ferns. And these ferns are unique in that they are somewhat succulent. And we'll see photos of these ferns in just a few minutes. The fourth group, Polypodiidae, are the true ferns, and this is where we'll focus today. The ferns that are in this fourth group have large fronds and a branching network of veins. So, okay, here are our most common fern families that we see in this area. And I'm not going to read the list, but you can glance down it. And I have them alphabetical by scientific family name on the left. I'm going to give you a brief description and show photos from each family of ferns. And I'm not going to get into a lot of detail, but again, the purpose of this just being to try and show you some of the most common ferns that are in our area. So we're going to start out with the first family, the Spleenwort family. And these are photos of ebony spleenwort. On the left, notice the shape of the pinna and the fact that it grows alternately up the rachis. On the right, you can see the shape of the sori on the backside of the pinna. There's a second species named black stem spleenwort that can be identified by the fact that the pinna are opposite rather than alternate, as you see here on ebony. So here's the side-by-side of the ebony spleenwort on the left and the black stem spleenwort on the right, showing the alternate pinna. Next is one of my favorites, the mountain spleenwort. You can see a photo of the sori on the lower right. And I've seen this fern only at higher elevations along the Blue Ridge Parkway, mostly on rocky walls and crevices. Another of my favorites is in the spleenwort family, and the last one in this family that we'll talk about is the walking fern. It's not real common, but it is a beautiful little fern, and I have found it at the Kellogg Center outside of Hendersonville, North Carolina. On the left-hand photo, you can see the sori on the backside of the frond. Besides reproducing by spores, this fern also reproduces vegetatively. And I don't have a photo of it, but from the Hollowell book, you can see that new ferns are produced at the tips of the older leaves. Yeah, fascinating. There are other spleenworts in the area, but these are the ones in this family that I find to be the most common. So let's talk about the chain fern family next. And the photo on the left shows the netted chain fern. The photo in the lower middle shows the fertile frond of the netted chain fern, which you can recognize by the very narrow pinna. On the right-hand side, I put a photo of the sensitive fern so that we can compare the shape of these two ferns, which are sometimes confusing to tell apart if you're just looking at the fronds. Even though they are somewhat similar in appearance, they're actually in two different families. The netted chain fern is in the chain fern family, and the sensitive fern, interestingly enough, is in the wood fern family. So the easiest way to tell these two ferns apart is to remember that the netted chain fern on the left has alternate pinna, while the sensitive fern on the right has opposite pinna. Oftentimes, the pinna on the sensitive fern on the right-hand side is often more lobed. You can see, especially in the lower leaves, you can see how much more lobed it is than the netted chain fern, but there is a lot of variability in these species, so you can't always use that as an identifier. So now I'm going to talk about two ferns in the Stipteridaceae family, which includes the bracken fern. And I'll tell a little story about the bracken fern. The bracken fern is one of the oldest ferns. It's found on all continents except Antarctica and in all environments except deserts. It's one of the oldest ferns with fossil records over 55 million years old. And how much further back it goes, we don't yet know. But keep in mind that the dinosaur extinction was 65 million years ago. So a long time, just to put it in perspective. Evolutionarily, the bracken fern may be considered one of the most successful ferns and probably has the widest distribution of any fern in the world. Global climate change has contributed to its rapid increase. Bracken fern, like heather, is typically found in open moorland environments. The fronds can grow up to 8 feet high, but typically are 2 feet to 6.5 feet high. I'm going to talk for a minute about the positives and the negatives of bracken fern. It's a very interesting fern. On the positive side, over history, bracken fern has been used for animal bedding, canning, soap. It's been composted as a rich mulch. Stand bracken fern, and they can tend to grow in very dense stands, gives cover from predators to small birds and animals, especially during the nesting season. The bracken fiddleheads, and which most of you know, the fiddlehead is the tightly curled frond as it's just emerging, the new frond. The fiddlehead has been eaten by many cultures throughout history and is still commonly eaten today. The fiddleheads are either eaten fresh, cooked, or preserved by salting, pickling, or sun-drying. The stems of the bracken fern are used as a vegetable in China, Japan, and Korea. Both the fronds and the rhizomes have been used to brew beer. The starch from the rhizome has been used as a substitute for arrowroot. Bread can be made out of the dried and powdered rhizomes, either alone or mixed with other flours. The indigenous peoples of the Americas cooked the rhizomes and peeled and ate them or pounded them into a starchy fiber for flour. In Japan, they used the starch from the rhizome to make a sweet dessert, a sweet confection. The Maori in New Zealand used the rhizomes as a staple food when away from home or hunting. They carried them with them. There's research underway that is looking at the bracken fern as a way to develop new insecticides. When you use it as a winter mulch in your garden, it's been shown to reduce the loss of potassium, nitrogen, and to lower soil pH. They even used the ash in the past for degreasing woolen cloth and in making forest glass in Central Europe. It's interestingly enough, it's a quick and easy remedy for nettle stings. If you rub bracken on the affected area, it will take out the sting. And oftentimes bracken grows near stinging nettle. So now on the negative side, bracken is invasive. It's a threat to biodiversity. It's been taking over from the grasses and heathers that traditionally grow on open moorlands. It releases a toxin in the soil that inhibits other plants from growing there. It's toxic to cattle, dogs, sheep, pigs, and horses. And it's linked to cancers in humans. They have seen a link between consumption of the fiddleheads and higher levels of esophageal and stomach cancers. There's a high rate of these illnesses in Asia, and the spores are even carcinogenic. Uncooked bracken, so if you eat it fresh, contains the enzyme thiaminase, which breaks down thiamine. So if you eat excessive quantities of fresh bracken, you can get vitamin B1 deficiency, which is also known as beriberi, if any of you have ever heard of that illness. So these are the pros and cons of bracken fern. I found this plant very interesting. So I'm going to leave it up to you all to form your own opinion about this fern, which for better or for worse is here to stay. So interestingly enough, what other fern is in this family? And I'm giving you a hint right here. So for those of you who guessed, yes, it is the hay-scented fern. These two are in the same family. They don't look to me like, you know, they're related, but they are. And according to the book, The Ferns of the Smokies, this family is characterized by large plants with hairs, not scales. And you can see the hairs in this photo here, and marginal sori. So you can see at the bottom of this page, you've got the hay-scented fern as one genus, and you have the bracken fern as another. The other ferns that are not in the United States that I could see, the other ferns that are in this list here under the direct children. So here's a side-by-side hay-scented fern on the left. The sori are formed by a flap of the leaf fused with an indusium, and it makes a tiny cup-like shape. And then the bracken fern on the right, where the sori are covered by a rolled over leaf margin. So you can see just the edge of it is rolled over. All right, so I'm going to go on now to the wood fern family. And the wood fern family is one of the largest families in this area, and the shapes of the ferns in this family can vary greatly. Let's start with the most common wood fern, the Christmas fern, which remains evergreen during the winter months. The easiest way to recognize the Christmas fern is by the shape of the pinna, which has an ear close to the rachis. And you can see my red arrow on the bottom right pointing to that ear on the pinna, right up against the rachis. The lady fern is also in the wood fern family, and it's fairly common in this area. It has long, curved sori. You can see those more clearly in that bottom right-hand photo. That's one way to identify it. And as I mentioned before, the sori curve over a vein on the back of that pinwheel. I've often heard people ask why some lady ferns have green stems or rachies and some have red. And from my research, and it was in that book, Knoll, both the green stemmed and the red stemmed forms grow in this area, and he identifies the red stemmed form as Forma rubellum. So it doesn't consider it a separate species, but just a different form. And I actually have both of them growing wild in my yard, both the red and the green. So here's the sensitive fern, which we talked about earlier when we compared it to the netted chain fern. And this is a good example of the wide variety of leaf shapes in the wood fern family. Keep in mind that the pinna are opposite on the sensitive fern, whereas they're alternate on the netted chain fern. Also, look at the skeletonized fertile frond on the right-hand photograph, where the pinna lobes curl over the sori to form a ball. And you can see the dried pinna in that photograph on the right-hand side. All right, so now for the more challenging and confusing wood ferns to identify. And this is where looking at the shape of the different parts of the fern frond become important. And someone earlier talked about how important it is to understand the shapes of these ferns and identifying them. So for example, look at the bottom of this slide. What is the shape of the lowest pinna pair? The red arrows at the bottom show the pinnules closest to the rachis. How long are they, or how short are they? In the bottom left photo, there's the intermediate wood fern. The pinnule closest to the rachis is shorter than the second pinnule. On the bottom right is the spinulose wood fern. And you can see that the pinnule closest to the rachis is longer than the others. On the top photograph, the marginal fern, again, you see that the pinna closest to the rachis is shorter than the one next to it. So this is one way to start when you're identifying these ferns. So now, in this next slide, look at the pinnules above the costa, and the costa is the midrib of the pinna, so the midrib of that leaf. Look to see if the pinnules are shorter or longer above the pinnule than below. So you see here in all these cases, above the costa or the midrib, they're shorter than the ones below. And to make things more challenging, wood ferns hybridize with each other. And so in one area, you'll see a combination of all of these things at times that can make identification very challenging. And then of course, look at the sori. Look at the sori and look at its position in helping you identify the wood fern. Where are they located? So on the left-hand side, the intermediate wood fern, the sori are located midway between the edge of the leaf and the midrib. On the right-hand side, the marginal wood fern, you can see that the sori are right along the leaf margins. And finally, remember to look at the overall shape of the frond. Look at the apex, the top of the blade. How quickly does it come to a point? Look at the overall shape of the blade itself. Is it triangular? Is it long and narrow? And then, of course, remember that the wood ferns can hybridize. So the climbing fern family is next. And this climbing fern is the only native species in the genus that's in this area. I've seen this at DuPont State Forest. I have not seen it at Pisgah. So in the top right photo, you can see that the very small fertile leaves are at the top of the plant. The bottom right photo is an enlargement showing how the edge of the leaf curls over the sori. So that's where they're located on this plant. Some of you may be familiar with the non-native climbing fern called Japanese climbing fern that grows in this area, but it has a very different leaf shape. Okay, let's go on to the adder's tongue family. And there are several ferns in this area, and I wanted to talk about the easiest way to tell the difference between the rattlesnake fern and the common grape fern, since those can be confused at times. So you've got a photo of the rattlesnake fern on the left, and look at my red arrow. You can see that the fertile spike comes right out of the junction of the leaf and the stem. So at the top there is where that fertile spike comes out. This is one key feature in identifying it. Also, the rattlesnake fern matures in late spring and early summer. The grape fern, on the other hand, matures in late summer or early fall. And on the right-hand side, again, do you see the sori are in little balls on the stem that's actually formed by the pinna curling around the sori. Here is the dissected grape fern, and there are several grape ferns in the area, but I find this one to be the most common. And you can see my red arrow in the photo in the center bottom showing that the fertile frond comes from the leaf, it comes from the soil level where it joins the leaf stem. So unlike the rattlesnake fern, where it comes out of the top by where the leaf and the stem meet, this is the easiest way to tell these two ferns apart. And as I mentioned, this grape fern matures in late summer and the blade stays green over the winter. And again, the fertile frond are similar in both, and the sori is in balls formed by the curled pinna. The last fern that I wanted to talk about in this family is the southern adder's tongue. It's not uncommon, but they're small and difficult to spot. And you can see a little bit of the similarity between this and the rattlesnake fern and the grape fern with the tightly curled balls on the fertile frond. You can also see that the ferns in this family are slightly succulent, which is a characteristic, as I mentioned before, of the Ophioglossaceae family. That's a tongue twister. Okay, so the royal fern is one of my favorites. There are 3 ferns in the royal fern family, and many times I see them growing together. If I find one and I look around, oftentimes I can find at least one other, if not both. So you have the cinnamon fern, the interrupted fern, and the royal fern, and each one develops spores in similar yet different ways. So here's a photo of the royal fern. And the pinna are very different from the other 2 in this family. They're very large and oval. You can see that in the photo on the left. And if you look at the photo on the right, you can see that the fertile leaves have skeletonized pinna, and they're located at the apex of that frond, whereas the cinnamon fern and the interrupted fern have them in different locations. So this is the royal fern. Here's the cinnamon fern, and it's a very tall fern, often 3 feet or more in height, and has a separate stalk. That's your fertile stalk. And it's cinnamon in color, which you can see. When the fertile stalk is not visible, because as soon as they're done shedding spores, they really, most of the time I see them just disappear from the plant. The easiest way to tell them apart from the interrupted fern, whose leaves are very similar, is to look for the fuzzy collar on the cinnamon fern where the pinna meets the rachis. And if you look at the red arrow on the lower right-hand side, you can see there's a little bit of a fuzzy collar right where the pinna meets the rachis, and you do not see that on the interrupted fern. So here's the interrupted fern, and we looked at that briefly before. It has the fertile pinna in the middle of the stalk, and once the spores mature, the pinna shrivel and even fall off, leaving an interrupted space along the rachis, hence the name interrupted fern. You can see that on this one. I'm going to talk just very briefly about the Polypody family. Appalachian Polypody and rock polypody both grow in this region, but they can be very difficult to tell apart. They are most often found growing on rocks and trees in moist areas. I've seen them both at DuPont at lower elevations and along the Blue Ridge Parkway at higher elevations. And we mentioned before, one thing to note is that the sori do not have an indusium or a flap of tissue that covers the sori. And you can see how brightly yellow colored they are. It's interesting to note that this fern is in the same family as the resurrection fern, which many of us have seen growing a little bit further south and along the coast. And the resurrection fern is known for its ability to dry out, curl up, turn brown when the weather is dry, and when the rain comes, uncurl, turn green, and continue their life cycle. So the resurrection fern has that characteristic. The polypodes do not have the ability to dry out and curl up, but they are in the same family. Okay, on to the maidenhair fern family. And this fern family has one of the most unique shapes of all the ferns to me. One thing to notice when you look at the maidenhair fern is how the sori form under the edge of a folded leaf, which you can see in the small photo on the left. There are other ferns in this area in the maidenhair fern family, but this is the most common one that I see. Okay, so the last fern family that we're going to talk about today is the marsh fern family. And this family, like the bracken fern family, has just two species that on the surface don't look related to one another, at least to me. And it is the New York fern and the broad beech fern. So the New York fern that you see here is very common, as I find it as common as the hay-scented fern. So one of the fun ways to remember how to identify this fern is to look at its shape. You see in the photo on the left that the fern tapers at the top to a point and tapers at the bottom to a point. So one of the ways to remember that is the saying, burn the candle at both ends, since both the top and the bottom taper to a point. And they say this is like New York City, where people are awake and active both very early and very late in the day. Another characteristic about the New York fern is they tend to grow in clumps of about 6 ferns. It's a loose clump, it's not a crown. So again, look for this the next time you're out walking and you see the New York fern, is that they tend to grow in these small clumps. So here is the second fern in this family, and the last fern that I'm going to talk about today, and that is the broad beech fern. And so here is a photograph of the broad beech fern. So you can see that it has a very unique shape. In the left-hand photo, notice the wings between the pinna along the rachis. It's a key identifier for this species, a beautiful little fern. There's another species called the northern beech fern, which does not have wings along the rachis. And it can be found by Klingman's Dome and Mount LeConte, but other than that, it's a northern US and Canada species. So you're only going to find it in just some very isolated areas. So, okay. Congratulations. We made it through the fern presentation. Hopefully you all stayed awake. These are the most common ferns that I see in this area. So please let me know if there are any questions. I think, Dan, you're fielding questions from the group, so I'm gonna.
Yes, I wrote down a few questions from the chat box.
Okay.
Some of those you covered quite well about what is a fern ally. I think you covered that after the question was posed. What about which ferns grow in upstate yards?
Well, I can tell you what grows in my yard, which of course is the Christmas fern, and very easy to transplant. They are so hardy. I've moved them around a number of times. And then of course the lady fern grows, the New York fern. I've seen some gardens in the area that have the broad beech fern and the maidenhair fern, but you do need the proper environment for those types of ferns. And even the cinnamon fern I've seen in a few yards, but you do need probably a better environment. And I can't tell you what the soil pH should be on those, but I would say look at your area and identify the ones that are there, and then try and encourage those to grow in your yard.
Yeah, I have 9 on my species list of my woods. You know, some of them will grow by the creeks, and some of them require different habitats like that.
Yes.
Another question is, would you be able to make this presentation available by email to the Native Plant Society folks?
Yeah, you were gonna, did you record today, Dan?
I did.
Okay.
I missed the first part. I thought I was recording, but right after we got through the books, and I got back to recording.
Okay. Okay. So yeah, it's up to you if you don't mind sending it out, and if we want to re-record it at any time, so you have the full thing, we can do that as well.
Yeah, our goal is to put this recording on the website. I'm not sure if we have the expertise to do that, but that's what we're
Okay.
going to try to do. Another question is, how is the ITIS different from the USDA plants?
Boy, that's a good question. I find them for the most part to be very similar to one another when you're looking at scientific names. In my opinion, I find the name change on the ITIS site sometimes before the USDA, but they're very close together. So I usually don't see a lot of discrepancies between the two sites. They're both government sites.
Okay. All right. The question was, where do the common club mosses fall? I think you answered that. You had a nice slide on that. How about one comment that it was just a comment to general was about the horsetail ferns, about how ancient they are. They're living fossils. That's the only current member that we have of that group of equisetids. Back in the late Paleozoic, this guy told us that there were plants up to 98 feet tall. They were like trees in ancient times. So that was an interesting comment.
Good, very good information. Thank you.
One other question is, you mentioned how old the bracken fern species was. Can you tell me that again? I
How
didn't.
old it was?
How old the bracken fern was? You talk about millions of years old.
They have found fossils that are 55 million years old for the bracken fern. And again, it may be older than that, and they haven't found any fossils, but they have found fossils that are 55 million years old.
Okay. Well, thank you very much. That was all the questions that I had written down from the chat box. Let me invite anybody that wants to unmute themselves to ask a further question. So we actually had 78 participants at the